Okay, so I'm doing the MyiMaths exercise, matching surds. First one is square root of 2 times the square root of 7. So I'm just going to go to my notebook here and start doing that one. So question 1, square root of 2 times the square root of 7. Well, the rule is that you can just write that as 1 surd or square root of 2 times 7, and 2 times 7 is 14, so my final answer is the square root of 14. So just back to iMaths, and I'll bring that over. And on to the next one, the square root of 32. Okay, and my options are 4 root 2, root 2, 41, 35, or 3. Well, let's try and work with that. So number 2, the square root of 32. Well, what I want to think about is how 32 breaks down. If you remember factor trees, 32 is 2 times 16. 16 is 2 times, not 2 times 2, but 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. So in other words, the square root of 32 is the same as the square root of 16 times the square root of 2. And the square root of 16 is a nice round 4. So the square root of 32 is the same as the square root of 4 times the square root of 2, which I think was one of the options there. There we are, square root of 4 times square root of 2, so I'll drag that over. Okay, next one, square root of 18 divided by the square root of 2. So let's just go to my little book there. So question 3, the square root of 18 divided by the square root of 2. So I'm writing the division like a fraction there. And the rule is that we can write that as a single square root, the square root of 18 divided by 2. Now 18 divided by 2, of course, is just 9. So that's the same as the square root of 9. And 9 is a square number. So the final answer comes to a nice round 3. So I'll just take that and drag 3 over on my screen. Okay, next one, square root of 22 divided by the square root of 11. So let's go to my book. Question 4, square root of 22, I'll write it like a fraction, divided by the square root of 11 is equal to the square root of 22 divided by 11 in a single square root there. 22 divided by 11 is 2, so that's just the same as the square root of 2. Let's see if that's one of my options. And there it is, the square root of 2, so I'll drag that over. Next one, square root of 41 squared. Well, square root and squared cancel each other out, so that's just going to be 41. And then the last one, square root of 29 times the square root of 49. Square root of 25 times the square root of 49. Well, the only option left is 35, but let's try and satisfy ourselves that it is 35. Okay, so I'll call that number 6. Square root of 25 times the square root of 49 is, well, the square root of 25 is just 5, and the square root of 49 is 7. So that's just 5 times 7, which is 35, and 35 was one of our answers there. So let's just mark that. Jolly good. And let's go on to question 2. Okay, so question 2, simplify these surds, press Q to get a square root sign. So the first one says square root 5 times the square root of 13. Okay, well, onto my book here. So exercise 2. So I'll call it question 1. Square root of, gosh, what was it? 5 times the square root of 13. Okay, so the square root of 5 times the square root of 13 is the square root of 5 times 13 in a single square root. 5 times 13 is 65, so that's the same as the square root of 65. That's not going to be able to be broken down into anything simpler because the 5 and the 13 are both prime numbers, so they can't be broken down anymore. So square root of 65 is just about as simple as that gets. So let's just type that in. So square root of 65, that's the first one. Okay, next one, square root of 3 times the square root of 147. So let's have a look at that. So, well, first of all, I'll just write that the square root of 3 times the square root of 147 is equal to the square root of 3 times 147, like that, which is the square root of, gosh, 3 times 147 will be 441. 441. Now, how does 441 break down? Well, it certainly doesn't divide by 2. Does divide by 3. So 441 divided by 3. I better get Desmos onto this. 441 divided by 3 is 147. So times 147. Now 147 divides by 3. That's 3 times 49. And then 49 is just 7 times 7. So actually 441 is 3 times 3 times 7 times 7. Okay, so it's the same as the square root of 3 times 3 times 7 times 7, like that, which I can write as separate square roots. Square root of 3 times the square root of 3 times the square root of 7 times the square root of 7. The square root of 3 times the square root of 3 is just 3. The square root of 7 times the square root of 7 is just 7. So that's just the same as 3 times 7, which is 21. So actually that one simplifies to 21. Okay, next one. Square root of 22 divided by the square root of 11. That's fairly straightforward. I'll call that question 3. Square root of 22 divided by the square root of 11 is just the square root of 22 divided by 11. 22 divided by 11 is 2, so that's the same as the square root of 2. Back to this one, and that's the square root of 2. How do I type that in? Square root of 2, and that's that one done. Okay, next one. Square root of 72 squared. Well, again, the square root and the squared cancel each other out, so that is just 72. That's fairly straightforward. Okay, the next one. Simplify these surds. Press a Q to get a Q square root sign. Root 2 root 10 times 8 root 11. Okay, so I'll call this question 4. So what was it again? It was 2 root 10 times 8 root 11. 2 root 10 times 8 root 11. Well, I can rewrite that with the 2 times 8 first. and the root 10 times root 11 next. 2 times 8 is 16, and root 10 times root 11 is the square root of 10 times 11, 110. So 16 root 110 is about as simple as that's going to get. If there were any common factors with these square roots, so like if 10, which breaks down into 5 times 2, had something in common with something that 11 breaks down into, then we might be able to simplify that a bit. But 11's a prime number, so that's not going to happen. So 16 times the square root of 110 is the answer for that one. 16 times the square root of 110, written like that, 16 root 110. Okay, the next one, 2 root 6, that's 2 root 5 times 6 root 5. Well, that is going to simplify a bit. So 2 root 5 times 6 root 5 is the same as if we do the numbers first, the 2 times the 6, and then the root 5 times root 5 at the end. Now 2 times 6 is just 12, and the square root of 5 times the square root of 5 is just 5, because that's what a square root is. So 12 times 5 is 60, so our final answer for that one is going to be 60. 60. Okay, the next one. 40 root 30 over 5 root 5. 40 root 30 divided by 5 root 5. Okay, well, we can treat the numbers, the regular numbers and the square root separately here. So 40 divided by 5 is 8, and the square root of 30 divided by the square root of 5 is the square root of 30 divided by 5, which is 6. So it's 8 times the square root of 6. And that's not going to break down any further because 6 breaks down into 3 times 2. 3 times 2 are just prime numbers, and there's no repeated prime numbers there. So 8 root 6 is as far as that's going to go. 8 root 6. Okay, and then the last one, 6 root 3, and all of that is being squared, all of it. So you've got to be careful about the fact that the whole thing's in brackets. So I'm going to call that 7. 6 root 3 squared. Now, because we're squaring all of it, that's like having each of the individual bits squared. So that's the same as 6 squared times root 3 squared. 6 squared is 6 times 6, which is 36. And the square root of 3 squared is just 3, because the square root and the squaring cancel each other out. So that's 36 times 3, and 36 times 3 is 108. So that's going to be 108. 108. There we go. Let's mark that. And 20 out of 20. Super duper.